Good morning, everybody. We're going to do experiment number 2 today. This is a quantitative analysis of a soluble sulfate. The primary objective of this experiment is to determine the percentage of a sulfate ion in a sample of sodium sulfate with impurity. And of course, if we have pure sodium sulfate, based on the formula, we can determine the percentage of the sulfate ion. We don't need to do this experiment. But unfortunately, the sample that we're using today is something with impurity. So we don't know, for a given amount of sample, we don't know how much sulfate ion is in there. And this is why we need to do this experiment to determine the amount of sulfate ion in sodium sulfate sample with impurity. And some of the terminology that you want to get familiarized, and when you read through the lab manual, you will see gravimetric analysis. Basically, that's the analytical process by measuring the mass of the different sample and making sure we have the correct mass measurement. Okay? And then selective precipitation, that's another thing that we will be using today. How do we determine the amount of sulfate ion in a given sample? We use something that we call selective precipitation. And then in the process, when you read the lab manual there, we also need to determine the mass of the barium sulfate sample. We want to make sure that we have the constant mass. Now, this is something that we talked about in Chem 101 already, and gravimetric analysis and constant mass, and you do those labs in Chem 101, you learn these terms there. And the only thing new here is probably this term, selective precipitation, and also a digestion process. We want to make sure that we got all of the sulfate ion out of this particular sample when we do selective precipitation. So when you read through the lab manual there, make sure you pay attention to these terminologies here. And safety is always our top priority, of course, and whenever you're in lab, you have to wear safety glasses and wear gloves when you handle chemicals. And waste disposal is another area of concern. When you finish the experiment, you don't want to just dump everything in the sink. Rather, we have designated area for waste disposal. We have different bottles, different containers, so make sure you follow the instructions, and the lab instructor will tell you where to put your chemicals and chemical waste when you finish the experiment. So let's take a look at something that we call selective precipitation. Okay? So this is the chemical reaction equation that we are using in this experiment. We have barium chloride, and we know barium chloride is water soluble. Right? So if you put barium chloride in water, you end up with an aqueous solution. And then we have sodium sulfate. Now remember, this is a sample with impurity. We dissolve certain amount of sodium sulfate in water, so you end up with aqueous solution. Now, two aqueous solutions, both are clear and transparent, okay? And then when you mix these two together, something happens. We end up with the sample that is not water soluble, barium sulfate, which is a white solid. Okay, and then we end up with sodium chloride. Sodium chloride, table salt, it's water soluble. So this is the overall chemical reaction equation. The net ionic equation, well, if this is an aqueous solution, we have barium ion, we have chloride ion. Okay, and if this is an aqueous solution, we still have chloride ion. So we got chloride ion on both sides of the equation. We don't have to list them because those are the spectator ions, and we can just cross them out. Right? So the net ionic equation is the barium ion reacting with the sodium sulfate ion, you end up with barium sulfate. So this is what we call selective precipitation. As you can see, the sulfate ion in the given impure sample is selectively precipitated out. Everything else remains in the water solution. Right? So now once you have a solid and liquid mixture, you can easily separate them by doing a gravimetric filtration. We have filter paper, we have funnel, you can just pour everything through the funnel, and then the liquid will go through, the solid will stay on top. So how do we determine the amount of sulfate ion in the orange sample? Well, once we collect the solid there, we can measure the mass of this solid. Now if we know the formula, if we know the mass, we can determine how many moles of this compound we have. And pay attention that in BaSO4, barium sulfate, each mole of barium sulfate will have 1 mole of barium ion in it, will have 1 mole of sulfate ion in it. If you know the mass of this sample, and if you know the number of moles of the sample, well, if you know the formula of the sample, if you know the mass of the sample, you can figure out how many moles of barium sulfate we have. And then from there, you can determine based on that 1-to-1 ratio, each mole of barium sulfate has 1 mole of barium and 1 mole of sulfate ion, we can determine how many moles of sulfate ion that is present in the sample that we collected. And that sulfate ion came exclusively from our impure sample. So we need to determine the mass of the sample. And once we have the mass of the sample, we can do all the calculation. So giving you another discussion about how we calculate the percentage here. The first equation that we have here, we want to figure out, and remember the primary objective of the experiment, we want to figure out the mass percentage of the sulfate ion in a given sample. So we are looking for the mass of the sulfate ion. How do we determine that? Well, we get the mass of the barium sulfate. We multiply that by here, and use some abbreviation there, MW, molecular weight. Really, I should say MM, molecular mass, right? So MW for SO42 negative, we have 1 sulfur, 4 oxygen, add everything from the periodic table together, we got the molar mass for the sulfate ion. Okay? Now, if you look at this part of the equation, it's the mass of barium sulfate divided by the molar mass of barium sulfate. That gives you the number of moles of barium sulfate. And if you have the number of moles of barium sulfate, that equals to the number of moles of the sulfate ion, because it's a 1-to-1 ratio. And then if you multiply the number of moles of the sulfate ion by the molar mass of the sulfate ion, you get the mass of, in gram, the mass of the sulfate ion. Now, if you know the mass of the sulfate ion, and that number, if you know the mass of the sulfate ion from equation A, divide that by the mass of the sodium sulfate sample. Multiply that by 100%. We get the percentage here. Now, this is an experiment, of course, and these are your, once you get this number here, these are your experimental results. We also want to know how accurate your experimental result is. So we want you to do a percent error calculation, and the true value minus the experimental value divided by the true value times 100. Now remember, your value could be either higher or lower than the true value. But we don't really care about the sign, negative or positive for the percent error there. We take the absolute difference. Okay? Now, you ask where do you get the true value? Your lab instructor will give you the true value of each of the samples that we use. We have different samples in lab there. So once you obtain the true value, once you have your experimental value, we ask you to do a percent error calculation in the sample. So pretty much, and these are all the things that we want you to know before we start doing the experiment. And again, the percent error, the smaller the better. And ideally, if you can get less than 5% error, that's a fairly good result. But if your percent error is more than 10%, you really need to look into the experimental procedure. Where could you introduce all that, the error into your result there? So that is the error analysis is a very important part for the experiment. So that pretty much concludes our pre-lab discussion, and we will move to the hood, and we will do a quick demonstration of how this experiment is done. So this is how we do the experiment. Okay, and we have a given sample. Okay, this is a sample of sodium sulfate with the impurity in there, and as you can see, we have a label on it. This is sample B. So we don't know what the percentage is. Right? So in this case, we measure out approximately 1 gram of the sample. We put it in a 250 milliliter beaker, and then we want to dissolve this solution. Now when you read the lab menu, this is what you see here. The lab menu asks you to use hot water to dissolve the sample. So we have to get a beaker and put some water in there, put them on the hot plate, and bring the water to boil. And here I have roughly about 100 milliliter of the boiling water. And all we need to do here is that once you have that 1 gram of sample in the beaker there, and you can just put the hot water in to dissolve it. Now, in order to make sure everything dissolves properly, the lab manual also asks you to add concentrated hydrochloric acid. In acidic solution, many salts will have a better solubility. Okay? So for that reason, we have concentrated HCl. Right? So we use a glass pipette with the rubber valve on top of it, okay? And we're going to take some hydrochloric acid from the container, and then we want to add that slowly and dropwise into the solution, just to make sure the solution is strongly acidic. Okay? So once we have the sample in there, we want to use a glass rod, and sometimes when you work in the lab long enough there, and then you see this kind of process there, the lab personnel will just shake the beaker like that and trying to dissolve the sample. Okay? So this is to dissolve all of the sample into the water solution. Now remember, this is sodium sulfate with impurity. Everything is supposed to be dissolved into the water there. And then the next part is adding barium chloride solution. And here we have a burette. Now we don't really have to use a burette, but the purpose of the burette is that we can accurately measure the amount of the barium chloride into the beaker here. Okay? So all of the sample is dissolved, and then we're ready to add the barium chloride. Now if you read the lab manual asks you to add barium chloride slowly with the boiling solution. Okay? So for the demonstration purpose there, we're not going to set up the hot plate or Bunsen burner to keep the water solution boiling. So we want to add the barium chloride solution into the beaker, and as you can see from the video, from the mixing of the two reaction there, as you can see, we start to form a white cloudy solid in the beaker. Okay? Now, one of the things that we talked about in the pre-lab is that we want you to understand the process of digestion. If you read the lab manual asks you to, once you finish adding the barium chloride into the beaker there, okay, once you form that white solid there, we want you to add the barium chloride slowly. And then once you finish adding, we want you to slowly cool down the hot solution. The lab manual even asks you to use cotton or glass wool to wrap up the beaker so that you can cool it down slowly. Now that is the process that we call digestion. Digestion actually promotes the formation of a larger crystal. A larger crystal makes it easier for us to do filtration and also gives you better purity for the sample we're trying to collect. Okay? So this may take a good 30-40 minutes before the solution gradually cools down to room temperature. Once the solution cools down to room temperature, we want to make sure by that time all of the precipitate will settle on the bottom of the beaker. So the top liquid in the beaker there would be clear. We want to make sure that we have finished precipitating out all of the sulfate ion. How do we make sure that is done? Well, we can add a couple more drops of barium chloride into the clear top liquid. If you see more precipitation, more white solid start to come out, that means you still have sulfate ion in the clear solution. You need to add more barium chloride. Now, if you add barium chloride and you don't see any more white solid formation, then that means all of the sulfate ion is gone during the first process of addition of the barium chloride there, and then you don't have to do anything. Let the solution cool down to room temperature, and then we're ready to do the filtration. Now, filtration, and we're using a piece of filter paper. So when you fold the filter paper, this is when you take the filter paper from the box, and this is the size of the 11 centimeter diameter filter paper. And we want you to fold the filter paper first by half, and then another half. Okay? When you open it up, we want you to have the filter paper on one side, there are 3 layers, and then on the other side you have 1 layer. So basically, this is a filter paper form. And what you can do is that you're going to take a glass funnel, and you're going to put that filter paper into the glass funnel. Now, in order for the filter paper to stick well with the glass, we need to wet the filter paper with some water. Okay? You can just squeeze some deionized water into the on the filter paper, and then press the filter paper so that it will stay in the funnel. And then we're ready to do the filtration. By the time you get all that done, the solution should be at room temperature. Okay? And we have a ring stand in the hood. So when we try to do the filtration there, we will just put an iron ring on the ring stand, okay? And then we're going to put the filter, the funnel with the filter paper in it. And we want to use another flask and trying to collect the filtrate. Remember, what we want is the white solid in the beaker. Okay? Now we're ready to do the filtration. Now one trick for doing a quick filtration is that the solution is all settled. All the solids are on the bottom. So you don't want to stir them up, right? You want to pour the clear liquid into the funnel first. And then when you have the majority of the leftover is the solid, that's when you stir it up. Okay? So this solution, obviously, for this quick demo there, hasn't completely settled yet. So when you do the filtration there, we're just going to pour the solution into the funnel. Okay? And keep in mind, you don't want to overflow the top edge of the filter paper form, because otherwise the sample can actually go from the outside, go through the filter paper from the outside. Okay? So in this case, when you're doing the filtration there, just want to make sure the tip of the funnel should be a little bit lower than the top edge of the beaker there, and you can see the liquid dripping through quickly. And then once you are ready to pour everything in, we'll just pour all the water, all the liquid, the entire mixture, we will just pour them into the funnel there. Now again, this process may take a while when you're doing this experiment in the lab, and sometimes it can take as long as 20-30 minutes for the entire filtration to finish. Now, once you have everything filtered out, you got the liquid in the beaker, you got the solid in the funnel on the filter paper there, and that's how we determine the mass of the barium sulfate. Because we know the mass of the filter paper to begin with, okay? And then once everything dries up, next time when you come to the lab, once everything dries up, you measure the mass of the filter paper with the sample on it, and you can determine the mass of the sample. That sample is the barium sulfate. And once we get the mass of the barium sulfate, we can go back to do the calculation. Okay? And using the three equations that we put on the whiteboard, we will be able to figure out the percentage of sulfate ion in the sodium sulfate sample. And that's pretty much all you need to do in this experiment. Now, if you're doing a lab and with 3 hours there, the lab instructor may ask you to do 2 trials, okay? And then with the same sample. And after the 2 trials with the same sample, you will be able to take the average, with the hope that the average percentage is going to be closer to the true value of the percentage of the iron sample. The last thing that we need to do is clean up. So now you have all the used chemicals and different solutions there. There is a waste station in your lab, and we just need to take everything there and dump everything into the waste container there. And since this particular experiment, the sample, when you finish the filtration, the sample is still wet. We're going to leave the sample in your drawer, and we will let it dry up over the week. And next week when you come back here, next time when you come back here, we will measure the mass. So you will not be required to turn in the lab report next time you come to lab. Rather, you will get the information, the last piece of information you need for the lab report, and then you finish your lab report and then turn it in the week after that, when you come back to lab.